Hello, welcome to Prejim Technologies. I am Venkat. This is part 41 of SQL Server. In this session, we'll learn about indexed views. Before continuing with the session, I strongly recommend to watch parts 39 and 40 of this video series. So what is an indexed view, or what actually happens when you create an index on a view? A standard or non-indexed view is just a stored SQL query. When we try to retrieve data from this view, the data is actually retrieved from the underlying base tables. So a view is just a virtual table. It doesn't really store any data by default. However, this default behavior can be changed by creating an index on that view. So once we create an index on a view, the view gets materialized. This means the view is now capable of storing data. In SQL Server, we call these indexed views, and in Oracle, they are termed as materialized views. Let's look at an example. I have product details table here, which has got product ID, name, and unit price columns. This table stores the master product details. On the right, I have product sales table, which stores the sales of products. For example, I have sold 10 quantity of product with ID is equal to 1. In this case, I sold 10 books. And the second row says I have sold 23 pencils because 3 is pencils. Okay, so basically this table stores the product sales data. Now, based on these two tables, I want you to create a view which can result this aggregated data that you can see on the right hand side. Okay, so I want you to write a view which can actually return the total sales and total transactions by product. So after selling books, what is the total amount of sales that I made, and how many times did I actually sell books? Okay, so if you look at books, total transactions are 4, meaning in the product sales table we should have made 4 transactions as far as books are concerned. The books ID is 1, so there should be 4 entries for product ID with 1. So 1, 2, 3, 4. So total transactions for books is 4. Okay, so now let's create a view which can produce this output. Now, we wanted to create an index on this view so it can get materialized. So obviously, if you want a view to be indexed, then there are certain rules that view should be following, okay, which we'll talk about now. Alright, so we want to produce this view that you can see on the right hand side, and obviously if you look at the view itself, I want the name, total sales, and total transactions, 3 columns there. Okay, so the first thing is, obviously when you're creating this view, if you look at the implementation of the view here, we are saying create view, view name, and we are using with schema binding option. Okay, now the first rule is that the view should be created with schema binding option if you are planning to create an index on that view. Okay, now we have already spoken about using schema binding option, and we have used the schema binding option with functions and stored procedures as well. Okay, so if you create a function or a stored procedure or a view with schema binding option, then you cannot change the underlying objects in any way that could affect that function, stored procedure, or view. That's what schema binding option is for. So if you are planning to create an index on a view, then that view should be created with schema binding option. That's the first rule. So the second rule, if an aggregate function is used in the select list, so if you look at this function, this view, we're actually using an aggregate function sum. And why we are using that? Because we want to compute the total sales made. So we are using the sum function. And obviously, if you want to calculate the total sales, how will you calculate that? We will multiply the quantity sold with unit price. So here is the quantity, and unit price is in the TBL products table. So we have to multiply this unit price with quantity sold and then sum that up for each row in this product sales table. So that's the reason why we are using the aggregate function, and we are multiplying quantity sold with unit price. Now let's say for some reason, product ID or quantity sold is null, and then when you multiply that, this expression could return null. So the second rule states that if you use an aggregate function in the select list, And if that aggregate function is making use of an expression, and if there is a possibility for that expression to become null, then you should specify a replacement value. Okay, so if this expression becomes null, what is the replacement value that I want to give to this sum function? Instead of giving it null, I want to give 0. Okay, and how am I doing that? I'm using isNull function. Again, we have spoken about different ways to replace null values in this video series. Okay, apart from null, you can also use case statement and coalesce functions. We have spoken about them extensively in a previous session in this video series. Okay, so the second rule is that if an aggregate function in the select list references an expression, and if there is a possibility for that expression to become null, then a replacement value should be specified. And here we are using isNull, and obviously we are giving as total sales an alias name for that column. Alright, and another important rule is, if you use group by in your view, here we are using that because we want to group by the product, the total sales and total transactions. So we are using group by. So if you use group by within your view, then the view select list must contain a count of big function, count underscore big expression. Okay, so obviously we actually need to count the total number of transactions here, so we are using count of underscore big. You can also use count function, but the problem is if you are planning to create an indexed view, you cannot use count. You will have to use count underscore big function. Okay, and the base tables in the view, this is the last rule. The base table in the view should be referenced with two-part name. So here this view has two base tables. What are those? TBL product sales and TBL product. So when you are referring to these two tables in this view, you should use the two-part name, the schema name and the table name. You cannot use one-part name, which is without schema, or you cannot use a three-part name or a four-part name. You will have to use only the two-part name, the schema name dot the table name. Okay, these are only a few of the rules, but for the complete list of rules, please visit this Microsoft URL. Please visit MSDN at this URL. There are a whole bunch of them, but for the purposes of this demonstration, to create this view, it's enough if we satisfy these rules. Alright, so let's create this view in action. So we exactly have the same view, create view, view name with schema binding option, as we need the name of the product, and we want to sum the quantity sold multiplied by unit price, and then we want total transactions. We are using count function, count underscore big function for that, from product sales joining with TBL product table. On the join condition is obviously the product ID, which is the common column between those two tables, and we are grouping by name. Again, if you're new to using group by class, we have recorded a video on this as well in the previous sessions of this video series. Please check that part. So let's execute this. Command completed successfully, which means this view is created now. Let's refresh the views folder and we should see the view. So obviously, to select the data from that view, we use select star from that view. Let's execute that. So we get the data as expected. Okay, so now we want to create a view on this. We want to create an index on this view. So if you look at, when we execute this particular statement, look at this. We have just created that view and we are executing the select statement on that view. So when we execute this query, what is actually happening? As it stands right now, this particular view is not storing any data. So when we execute select star from this view, what is actually happening behind the scenes? The database engine will actually execute this select statement, which means the query has to go back to these base tables, and then it has to compute the sum, the total transactions, everything, and it has to group by them. Okay, so it has to, every time you say select star from this view, it has to every time compute those. So obviously, if your product sales table is huge, Because just imagine, companies like Amazon, Microsoft, etc., they will be making millions and millions of transactions. So if you want to sum them up every time you execute a query, just imagine how much time it's going to take to compute those results. Okay, but here, since we haven't created an index on this view, the query will have to go back to the base tables and evaluate these expressions every time you execute select star from this view. We can change that by creating an index on the view. Okay, so to create an index on the view, we are saying create unique clustered index. This is the name of the index on this view. And remember, the first index that you create on a view should be a unique clustered index. And it makes sense because this view itself, as it stands right now, it doesn't store any data. So you cannot create a non-clustered index, if it doesn't already have any data at all in that view. So the first index that you'll have to create should be a unique clustered index. Okay, so create unique clustered index, and we are giving it a meaningful name on this view, on this column, on the product name column. Okay, so let's create that view index. Execute that command, completed successfully. So if we expand this view indexes folder, you should see the index that we have just created. So now when I execute this query, it will return that data from that index itself. It doesn't have to go back to the base tables to compute that. Okay, so anytime a transaction is made and if there is a row entered into this table, the view is also recomputed and updated. So anytime people issues the select star from that view, the calculations are done pretty fast, and it can significantly improve the performance of your query. Okay, and basically indexed views are suitable at places where the data is not changed heavily. Okay, so these indexed views are ideal for OLAP systems, in a data warehouse environment systems, where the data is not changed, on where the data is not frequently changed. Mainly the data in a data warehouse is used for reporting and analysis purposes. Okay, maybe every week or every night they just batch load the data and then it gets reprocessed. But then the best way to load the data when you have indexed views is to basically drop those indexed views, load the data, and then recompute or recreate those indexed views, which will definitely increase, reduce the amount of time that it will take to process the data. So these indexed views are suitable for environments where the data doesn't frequently change. But for OLTP systems, indexed views might affect the performance because they change on a constant basis whenever a new transaction is made, and we will have to continuously readjust this indexed view, which could actually affect the performance. So that's why, and another thing to keep in mind is that the cost of maintaining indexed views is much more than the cost of maintaining table indexes. Okay, so mostly these indexed views are used in a data warehousing environment rather than in an OLTP system. On this slide, you can find resources for ASP.NET, C#, and SQL Server interview questions. If you want to receive email updates when new videos are posted, please subscribe to my channel. That's it for today. Thank you for listening. Have a great day.